Hello everybody, welcome to chapter 3.1. We're going to talk about exponential functions today. We're going to split this up into two parts. So in this video we're just going to cover the basics of what makes up an exponential function, and we're also going to talk about key characteristics of their graphs and transformations. So to begin, let's talk about what every exponential function is going to look like essentially, what all the parent functions are going to look like. So what we can say is an exponential function with a base A, should use the quotations, A is denoted by f of x equals a to the x, where what we are substituting into these exponential functions is the exponent, the power. Let's just do some examples of these and kind of start to explore. So for example, we're going to consider the functions f of x equals 2 to the x and f of x equals 4 to the x. We're going to graph both of these in our calculator, and then we're going to kind of see what happens with them. We're going to look at their table and their graphs. So we'll start by going to Zoom, and we're going to go to Zoom Standard just so that we have a standard looking graph. We're going to go to y equals, and I see right now that I have some things going on in my calculator, so I'm going to fix that. I'm going to go to apps. I'm going to go down to inequals. I'm going to make sure that that is not running. I'm going to quit that. And now I'm going to go back to my y equals. Now I'm going to put in both of those functions. So I'm going to write in, type in 2 and then caret to the x. And then below that I'm going to do 4 caret to the x. So when I look at the graph as it creates these two, the first one it's going to create is 2 to the x, the second one is going to be 4 to the x. So let's press graph to see what those look like. Alright, that's 2 to the x, and there's 4 to the x. Some interesting things are happening here. We can see right away that they look very, very similar. For all of the x values from negative infinity up until we get to right about here, about negative 2 or so, that's when they start to become a little bit different. It looks like they're both increasing. They're both going upwards. But it looks like 4 to the x is increasing a little bit steeper than 2 to the x. So it looks like 4 to the x is increasing faster. And it looks like they're both crossing the y-axis at 1. To confirm that, though, let's look at our table. So let's press second window, and let's start our table at where we think that y-intercept might be. Let's look at when x is 0. Or you know what? Let's take a look at negative 2. Let's start there. That's when they really start to get kind of different. In our change in table, let's just make that 1. Okay, now let's press second graph. And we can see some interesting things are happening here. Here we have 2 to the x, or y1, and it looks like we had 1/4, 1/2, 1, 2, 4, 8, 16. And what we see going on here in our y values is that exponential increase. We don't have an arithmetic change. We have an exponential change in all of these y values. And that makes sense given that our x values were an exponent. For our 4 to the x, we can see our y values Again, they both have that y-intercept of 1. That's interesting. But from there, they increase at different rates. 4 to the x is increasing much, much faster. We can see that those y values get a lot bigger, a lot quicker. Just like we saw on the graph. Very interesting. So what we can conclude from this is that both are increasing, but 4 to the x is increasing faster. Increasing faster. Oh, there we go, sorry. Let's look at a slightly different example. When f of x equals 2 to the negative x, and when f of x equals 4 to the negative x. So I'm going to do exactly what I did last time. I'm going to go to my y equals, and I'm just going to change this real quick. I'm going to press insert, so I'm going to go second delete, and I'm going to insert a little negative sign. I'm going to do the same thing with 4 to the x, so I'm going to go second delete, and then I'm going to press my negative sign. Now I'm going to press graph. Alright, some interesting things are happening here. Here's 2 to the negative x. Here's 4 to the negative x. It looks like these are almost the same graphs, but it looks like they are just reflected over the y-axis. Very interesting. And now, because they were reflected, they are no longer increasing, they are decreasing. They are going down from left to right. Decreasing functions now. And just like before, it looks like they're both decreasing, but 4 to the negative x is decreasing at a faster rate. It is a little bit skinnier, so it's kind of changing faster. Again, it looks like they are very, very similar. It looks like they get very, very, very close to the x-axis as we approach positive infinity over here. That looks very much the same, but the differences lie here in their decreasing rates. And it also looks like we still have that y-intercept at 1. Let's look at our tables, though, just to be sure. So let's go to second table set. Let's begin again at, let's say, negative. Let's look farther in the negative direction this time because that's where the changes are really happening. So let's begin, let's say, at negative 5. And we'll keep our change at 1. And now we'll go second graph. Okay, again, this really confirms what we were just seeing in the graph. Here is 2 to the negative x, here's 4 to the negative x. You can see that they have much different values, right? Just like before, 4 to the x is, negative x is decreasing at a much faster rate. We have these really, really big values, these really, really big jumps in values. Whereas the change in values for 2 to the negative x are a little bit smaller, so it's not decreasing as quickly. As we move past 0, we can start to see, again, that they are both approaching those really, really tiny numbers, so it does make sense then, just like we saw in our graph, that we are approaching the value of 0 on the y values, so we are approaching the x-axis as a horizontal asymptote. And again, what we have is a y-intercept at 1. So again, a basic takeaway that we can do here is just say that both are decreasing this time. However, it's important to see that 4 to the negative x is decreasing. Make sure you guys can see that. Okay. Faster. Another important thing to see here is that 2 to the negative x and 4 to the negative x can both be rewritten as 1/2 to the x and 1/4 to the x. kind of interesting stuff is happening there with that. Because we have that negative exponent, remember that means you have to move everything to the bottom. So that's why we actually have these fractions instead of whole numbers. So these are equivalent equations. And here's some basic takeaways that it's important that we understand about these exponential functions. And we've kind of already talked about all of this, but when we have an exponential function, a to the x, we know the following things about this. Just like we saw in all of our graphs, the domain is everything from negative infinity to positive infinity. These are continuous functions. That means they don't stop, they don't jump, they don't do anything where you'd ever have to lift up your pen or your pencil if you decided to graph them. The range, however, we also noticed it was kind of interesting in our tables. We got really, really, really close to 0, but we never actually touched it, and we never went below 0. And that makes sense, so that our range would be everything from 0 to positive infinity, everything above 0 on the y-axis. And again, that makes sense because exponents can't be negative numbers, right? If you were to I'm sorry, I should clarify. The difference there is that our a values have been greater than 0. Whenever we have a negative in front, that is when, in fact, our range will be negative numbers. But unless we have that negative in front, they will always be using the x-axis as a horizontal asymptote. Okay. We also noticed that there's always the y-intercept at 0, 1. And again, just like we were saying before, there is no x-intercept. What we saw instead was that there was a horizontal asymptote at the x-axis. So y got very, very, very close to 0, but never actually touched it. And lastly, we know that this is an increasing function. Y equals a to the negative x, or y equals 1 over a to the x. Again, domain was exactly the same, just like we saw on our graphs. It was everything from negative to positive infinity, all of our x values. The range was, again, everything from 0 above, everything from 0 to positive infinity on our y values. We saw the same y-intercept happen again at 0, 1. We saw again that there was no x-intercept, that we had a horizontal asymptote once again at the x-axis. The one difference here now is that it's a decreasing function. Okay. Now let's talk about some basic transformations of exponential functions. Okay. So, transformations. That's the topic we're on now. I'm just going to give you some basic knowledge that you should have about these, and then we'll go through on the graph and really explore some actual examples of them. But basically, if you have y equals a to the x, and then we have a little plus a number right here next to the x, so plus b, I'm not sure, plus whatever, then that means that our graph is going to the left. Did I do that correctly? Yes, 1 unit, or pardon me, however many units to the left. So I'm just going to say left b units. Conversely, if I have y equals a to the x minus b, then that means that I'm going to the right however many b units. are there. We talked about how if I have y equals a negative a to the x, that is when we'll have negative values in our range, because that means a reflection over the x-axis. If I have y equals a to the negative x, we already saw this in our own graphs. I'm going to write that a little bit closer, pretty far above. Okay, there we go. A to the negative x, we saw that that was a reflection over the y-axis. That's what changes our exponential functions from increasing to decreasing. Reflection over the y-axis. Lastly, let's talk about when we have an a to the x and then we have a plus a number at the end. Just like we've always seen, you guys, whenever we have plus or minus a constant at the end of our function, that transformation is either up if it says plus, b units, or that means down b units if it is subtraction. Addition means up, subtraction means down when we have that constant at the end. Let's do some quick examples of this on a graph. So let's start with some parent function, something to compare to. Let's start with a 3 to the x. That's what we're going to compare everything to. Now, let's look at our first transformation. If we did x plus a number, so let's do 3 to the x, and then, I don't know, let's say plus 2. So we should see our graph now go to the left 2. Let's see what happens. Oh, my zoom is not correct, so I'm going to press on. I'm going to press zoom. I'm going to go Z standard and fix that. There we go. All right, so here we have 3 to the x. And look at that. It did, in fact, just like we said, go to the left 2 units. So that makes a lot of sense. All right, let's try one more for good measure here. Let's try minus 2. X minus 2. And we know that that means it should go to the right this time. Let's double check. Here's our 3 to the x. All right, lo and behold, we have 3 to the x moved over to the right 2 units. So that is matching exactly what we said. Let's check putting a negative in front of the whole thing. So let's delete, and now let's press insert, second delete, and we'll put a negative 3 in front. All right, there's our 3 to the x. And there we have it, that reflection over the x-axis. That's exactly what that should look like. Let's try when we do 3 to the negative x. Again, we know what this should be doing. It should be reflecting over the y-axis, but let's just double check. 3 to the negative x. There's 3 to the x, and we should see another one coming in kind of like this. And there it is. That's a reflection over the y. Okay. And lastly, let's do these next two together. Let's say plus 2 at the end, and let's say minus 2 at the end, just to double check that we should be going up and down. So here is our 3 to the x once more. We should have one that's coming in a little bit above. There it is. And one that's coming in a little bit below. And there it is, making a lot of sense. Okay, so those are some basic transformations. That's all I have to show you today. We'll see you in class tomorrow.